Okay, now we have a problem here where I have vehicles. Each rectangle is a snapshot of a vehicle. A for after, B for before. So it's going 10 meters per second, and then it changes its velocity to 20 meters per second, correct? So that's before and after. These are the vectors, the velocities, correct? Yes? So the before velocity is 10 meters per second, the after velocity is 20 meters per second. It says in the problem to rank them in terms of the most positive to the most negative in terms of change in velocity. What has the greatest positive change in velocity? So, you've got to look at them. This goes from 10 to 20, so that's a positive. Remember, it's always final minus initial. And that's going to be change in velocity. Is always final minus initial. It's not initial minus final. In chemistry and physics, when you have to look at a change, it's always the final minus initial, not the initial minus final. Do you understand? Imprint that into your brain. It's always final minus initial, correct? Yes or no? Okay, now, let me just check one thing. Okay, they're all moving in the same direction. Okay, so what's the change here? What's the change here? Give me a number. Positive 10. You've got to put positive 10, right? Yes? You can't just put 10, can you? So this is positive 10. What's the change here? Negative 5. What's the change here? Positive 10. And what's the change here? 0. All right, so rank them in order from greatest positive change to greatest negative change. How would you rank them? How would you rank them? Anybody? Let's put it up here.
A, C, D, B.
You'd say A, C,
No.
D, B.
No.
First of all, let me ask you a question, not for nothing, but does positive 10 equal positive 10? Does it? I hope you see that.
Yes.
That's a little scary. So wouldn't A equal B? So wouldn't that be the greatest? Would be first? A and C are first, correct? Or no? Okay, are you on the right problem now? You're on the wrong problem, and that's okay. That's okay. All right? Okay. Professor Iman, are you with us or no? Are you with us? Okay. So we would say A equals B. That's first. Now what? What's next?
A equals B, and then D.
D. Excellent. D, and then anybody? Luke?
C.
C. Okay, a little painful, not bad. You guys did it. I feel like Who Wants to Be a Millionaire? Is that your final answer? Anybody ever see that?
Yes.
It takes them forever to answer sometimes, doesn't it? It's like just want to draw it out of them, you know? You know the answer. Yes?
Oh, I was just saying, I want to be in the show.
You want to be in the show? Excellent. You got to be on the right page, though.
Yes.
Okay. All right. So that's a good problem. Let's turn it off and we'll prepare for the next one. Okay?
Yes.
All right. Oh. There's one more part to the problem. It says rank from greatest acceleration to least acceleration. Right? greatest acceleration to least acceleration. Now, isn't acceleration change over velocity divided by time? Isn't it? But they don't give you time. So what can we assume? What can we assume? That the time frame is the same for each picture, right? A, B, C, D, time is the same. So rank them in order of greatest acceleration to least acceleration. What would be the order? What would have the greatest positive acceleration?
A.
Would it be the same?
Yes.
It would be exactly the same. It would be A equals B, then it would be D, and then C. Correct? You see that? All right. We're off.
It says on the sheet